of the subscriber, the actual phone number. Then we have authentication key and algorithms for authentication check. We have a charging information list of subscribed services, then PIN and PUK. Then temporary location, temporary information like TMSI, like temporary mobile subscriber identity and location area identifier. It also carries IMEI number, which is very important, which is used in theft protection. Okay, and without SIM, you can only make emergency calls. Okay. For GSM 900, we have the MS transmits power up to 2 watts. For GSM 1800, it takes 1 watt because of smaller cell size. So MS mobile station, it also contains a display, loudspeaker, Bluetooth interface, IRD, etc. Next, we'll see about RSS. So RSS consists of, which is nothing but the base station subsystem. So it contains many BSS and performs all the function necessary to maintain the radio connection to an MS, which is decoding, coding, decoding, rate adaptation, etc. And the interface between these two is ABIS, which is air interface. Okay, and each BSS consists of BSE and BTS. We have already talked about BTS. BTS consists of radio transmitter, receiver, signal processing and control equipment, antennas, and feeder cables. You can see the picture of your antenna, your BTS. So the purpose of BTS is to provide radio access to the mobile station, manage radio access aspects of the system, encode, encrypt, multiplex, modulate, and feed the RF signals to the antenna, frequency hopping, and it communicates with the mobile station as well as the BSE. So BSE, what is the purpose of BSE? Is it actually manages all the BTS. Okay, along with it allocates a channel for the duration of the call. So whenever there is a call, a channel will be allocated for this call. Okay, it maintains the call. It monitors the quality of the call, controls a power transmitted between the by the BTS or MS, generates handover whenever to another cell whenever it is required. Okay, BTS can be linked to parent MSC by microwave, optical, fiber, or cable. It can be any of these. We'll see about NSS, which is the heart of the GSM. NSS stands for Network and Switching Subsystem. Okay, it connects wireless network with a standard public network. It performs handovers, supports roaming, charging and billing. Everything is taken care by NSS. You can see the NSS components, which is the MSC and the databases, which we have talked about earlier, and it uses SS7. So MSCs are nothing but digital ISDN, high performance digital ISDN switches. The setup and control connections to other MSCs and to BSCs via A interface. So already told, this is the heart of the GSM. It manages, one MSC manages several BSCs in that particular location. It controls all connections via a separate network to or from a mobile terminal within the domain of the MSC. So what are the functions of MSC? Mobile Switching Center. Okay, you can see now, it switches calls, controls calls, logs everything about the calls. Specific functions like paging and call forwarding is taken care. Mobility servers, specific signaling happens. Mobility management over radio network and other networks. Radio resource management, that is handovers between BSCs, is taken care by MSC. Billing information, location registration and forwarding of location information, provision of new services, support of SMS, generating and forwarding of accounting and billing information, interface with PSTN, ISDN, PSPDN, interworking functions, which is IWR via gateway MSC. Okay, a particular, what is this gateway MSC is nothing but MSC can act as a GMSC. Okay, it is a device which routes traffic entering a mobile network to the correct destination. It accesses networks HLR to find the location of the required mobile subscriber. The operator may decide to assign more than one GMSC. Next, we'll see about NSS, home location register. Okay, this is very important because it contains all the information about a mobile subscriber. Okay, and its and his subscribed services and IMSI numbers, and dynamic information like current location area and MSR and mobile subscriber roaming number, the current VLR and the MSC. As soon as MS leaves its current location, the information in the HLR is updated. This information is required to localize a user within the GSM network. All this information is available only in HLR, which supports charging also. So you can see that logically there will be only one HLR, but it may be split in region wise. So, and each HLR has to manage data for several million customers, containing high specialized databases, which will be rather super fast. Okay, and it uses SS7 network. It again works along with the authentication center that is present in OSS. So what is VLR? So VLR is nothing but visitor location register. It's a dynamic local database register, unlike your HLR, which contains both static and dynamic. It stores all the information required for an MS to localize within that particular region. Okay, if a new MS comes into the LA of the VLR, it copies all the relevant information from the HLR and stores it temporarily. Okay, what are the information that is stored is IMSI number, MSISDN, MSRN, anti-MSI. Okay, the location area where the mobile station has been registered and all the supplementary service parameters that is required for supplementary services. Now we will see about OSS. So OSS is again a centralized operations management and maintenance of all GSM subsystems. It accesses other components via SS7 signaling. It consists of the following things like OMC, authentication and center, and EIR. What is OMC is nothing but it is having different control capabilities for the radio RSS and the NSS via O interface. Okay, the interface that is used here is O, and it uses SS7. So it monitors traffic, reports the status of all the network entities within the OSS, subscriber and security management, accounting and billing. Authentication center works along with HLR and the NSS. So what does this authentication center do is it stores all the data and protects the user identity and data transmission. Authentication parameters used for mobile terminals and encryption of user data on the air interface within the GSM system. It also generates user-specific authentication parameters on request from VLR. Okay, so whenever there is a call initiation, the VLR will be requesting the authentication parameters that will be required for establishing a call. So it is situated in a special protected part of the HLR. Now we'll see about EIR, which is nothing but Equipment Identity Register. EIR is a database for all IMEI. It stores all device identification registered for this network. So within a network, how many of our mobile phones are available? All the mobile phones IMEI number is stored in EIR. Okay, and whenever possible, you can actually query for this IMEI number. Okay, the status levels are whitelisted, graylisted, and blacklisted. What is whitelisted is the terminals which is allowed to connect to the network. They are called as whitelisted numbers. Graylisted is the terminal is under observation by the network for any possible problems. Whereas blacklisted means that the terminal has either been reported stolen or is not type approved by the GSM network. Then this terminal will not be allowed to connect to the network. So this is the use of this EIR. Okay, we'll see about localization and calling, GSM operation, localization and calling. What happens in GSM is automatic localization of the users happen. Okay, so to provide us this service, GSM uses periodic location updates, even if a user doesn't use the MS. Okay, similarly, your HLR will contain all the information regarding the current location of the user, and VLR will be responsible for MS, informs the HLR about the location changes. Okay. As soon as the MS moves out of the range of, moves into the range of a new VLR, the HLR sends all the required data to the new VLR. Changing VLRs with uninterrupted availability of all services is called as handover or roaming. So how to locate an MS and to address its several numbers? We need all of these numbers. MS ISDN, mobile station international ISDN number, which is nothing but it consists of the country code, address of the network provider, and the subscriber number. Then we have IMSI number, which is nothing but international mobile subscriber identity. It is unique. It is an internal unique identification of the subscriber. Then we have TMSI, which is nothing but temporary mobile subscriber identity to hide the IMSI, which would give away the exact identity of the user. We use TMSI instead of that, which is a 4-byte number selected by the current VLR and is valid only for that particular location of the VLR temporarily. Then we have MSRN, mobile station roaming number. This is another temporary address that hides the actual identity and location of the subscriber. The VLR generates this address on request from the MSC. This address contains the current visitor country code, the visitor network provider, the identification of current MSC with the subscriber number. So all these numbers are required for a subscriber to maintain a connection, to find localize a subscriber and to maintain a connection with the mobile station. Okay, so there are two kinds of calls. One is outgoing call and another one is incoming call. Outgoing call, we call it as a mobile originated call. Okay, and the incoming call is called as mobile terminating call. We'll see about both these calls now. Now we'll first see mobile originated call or outgoing call. So you can see the numbers being represented in the diagram. 1,2 is the connection request. One is between MS and BSS. 2 is between BSS and MSC. MS sends a dial number to BSS. BSS sends this dial number to MSC. 3.4 talks about the security check. MSC, what it does is it checks with the VLR if the MS is allowed to take the requested service. If so, MSC asks BSS to allocate resources for call. Then 5 and 8 is to check the resources to establish the connection. MSC routes the call to GMSC, and GMSC routes the call to the local exchange of called user. Okay, in turn, it is available if the resources are available, this connection is established.